Hi and Assalamualaikum everyone. Today we are going to present about our topic which is waiting line and queuing theory. Before we start, we would like to introduce our group member.
Hi, my name is Nur Farsanana binti Muhammad Farid. Hi, my name is Nur Iman Humaira binti Muhammad Faizan. Hi, my name is Nur Alia Fito binti Jafar Siddiq. Hi, my name is Su'aina Sudi binti Mustafa. Hi, I am Nur Faradiana binti Muhammad Fazli.
First, we start with our introduction. Our location is at TF Value Mart Tapa Road, Perak. The supermarket operates daily from 10 am to 10 pm. During our observation in 1 hour, we record 630 customers that enter the supermarket and 216 customers were served and exit. A manual queuing system is used with 3 service counters available for customers.
That's a drop top coupe. Said you wanna drive it down real soon. I just wanna love you like I do, cause I never had someone like you. Ain't nobody got this love, got me cuffed. Ain't nobody, babe. All I need is love.
Next, characteristic of a queuing system. First, arrival characteristic will have 3 types of arrival characteristic, which is size of the calling population, pattern of arrival at the system, and last, behavior of the arrival. For size of the calling population in TF Value Mart is unlimited, which is infinite, where the number of customer arrival at the TF Value Mart is unlimited. For pattern of arrival at the system in TF Value Mart is random arrival, where considered random when they are independent of one another and their occurrence cannot be predicted exactly, where the lambda equal to 630 customer per hour. And last, for behavior of the arrival in TF Value Mart is patient, where the customer wait patiently in the queue until they are served.
Next, we move to waiting line characteristic. There have 2 types of waiting line characteristic, which is the length of a line and queue discipline. For the length of a line in TF Value Mart is unlimited, where there is no maximum limit to the number of customers in the queue, and the TF Value Mart customer can join the queue even the queue becomes very long. And for queue discipline in TF Value Mart is FIFO, which is first in, first out, where the TF Value Mart customer who arrive first at the payment counter is served first.
2.3 Service Facility Characteristic. Number 1. Number of channel. The number of serve is F equal to 3. Since there is more than one serve, the system is a multi-channel system. Number 2. Number of pays. For this system is single pay system. This because customer receive service from only one counter and then assist the system. Number 3. Number of waiting line. Each counter has its own waiting line. Customer queue according to their respective counter. So this system has a multiple waiting line. Now I will to talk about basic queuing system configuration. We can indicate that TF has a multi-channel and single-pay system. So based on diagram, we know that customer arrive and wait a queue to make a payment at the counter, which is service facility. Then customer will exit the system after finish make a payment.
Now, I will explain the queuing model and the parameters used in this analysis. For this system, the arrival rate denoted by lambda is 630 customers per hour. This means that on average, 630 customers enter the system every hour. This reflects a high demand for the service. Next, the service rate represented by mu is 216 customers per hour per counter. This means that each service counter is able to serve an average of 216 customers in 1 hour. Since service times are assumed to be exponential, the service speed varies, but this is the average rate. These parameters are then used in QM for Windows to evaluate the performance of the system. Now, I will explain the results obtained from QM for Windows in more detail. First, the average server utilization, which is 0.97. This means that the service counters are busy 97% of the time. In other words, almost all available service capacity is being used. This indicates that the system is highly utilized and operating very close to its maximum capacity. While this shows efficiency, it also means that there is very little idle time, which increases the risk of congestion during peak hours. Next, the average number of customers in the queue, denoted as LQ, is 33.18 customers. This value represents the average number of customers waiting in line before being served. A queue length of more than 30 customers suggests that customers experience significant waiting time, which may lead to dissatisfaction, especially if service demand increases. Next, the average number of customers in the system, represented by L, is 36.1 customers. This includes both customers waiting in the queue and those currently being served at the counters. Since there are 3 servers, this means that most of the customers in the system are waiting rather than being served, reinforcing the idea that the system is under heavy load.
Next, the average time in the queue, denoted as WQ, refers to the average amount of time a customer spends waiting in line before receiving service is 3.16 minutes. This means that, on average, a customer waits approximately 3 minutes and 16 seconds before being served. For average time in the system, denoted as W, represent the total time a customer spends in the system, which includes waiting time in the queue and service time. The value obtained is 3.44 minutes. This shows that for arrival until service completion, a customer spends only about 3 minutes and 26 seconds in the system. The final parameter is P0, which represents the probability or percentage of time that the system has no customers. In this table, the value for P0 is not shown, so it does not mean the value is 0. It simply means the data is not provided in this output. Without the value of P0, we cannot say exactly how often the system is empty. But based on the short waiting time and system time, the system is working efficiently.
Lastly, for the conclusion, based on the analysis of the queuing system at TA value Matapa, the MMS model shows that the current service counter are generally able to handle customer arrivals. Customers are generally satisfied with the waiting time. However, during peak hours, customers may still experience waiting time. Improving queue management or adding counter during busy periods can help reduce waiting time and increase customer satisfaction.
So, what can we learn from this project? Firstly, we can apply queuing theory to real-life situations, especially in supermarkets operation. Second, we can improve our communication, cooperation, and teamwork skills. Last but not least, we can be able to understand the basic concept of queuing theory, such as arrival rate, service rate, and waiting time.